Good day to everyone. So in the last class, we have discussed about the Euler's method and how this Euler's method used to solve the differential equation, first order differential equation. And we have seen the some of the programs with examples with programs and how this solution is actually converged to the true solution when you are increasing the time, decreasing the time step, which we have seen in the last video. So I already as I already said that this Euler's method is a first order method, so that the error between the true solution and the exact solution is the true solution and the numerically calculated solution is somewhat high, so that we can go for the alternative method to reduce the error size. So which is we are going to see is the modified Euler's method. Modified Euler's method is also known as the Heun's method. So what we have to do in the Euler's method is, so we are actually finding how this y is actually varying with respect to x. So at discrete points, we are actually calculating the values of numerical solutions at x of I and x of I plus 1. Suppose this curve is actually true solution and x of I is the initial condition which is given, so that we are actually calculating this value, that means the corresponding yi value, and this value is actually taken as the initial condition, and you are going to use the linear extrapolation method to calculate the to find the slope, and this slope is actually going to meet this x of I plus 1 at some point here. So that is actually the equivalent value of y of I plus 1. So this will be the numerically calculated value, and the difference between the true numerically calculated value and the exact solution is called the error. So this is how this Euler's method is work. So we are actually using the initial condition or initial value. You are actually extrapolating the next value at some time step of h. So which is actually given by the equation y of I plus 1, which is y of I plus 1, which is equal to y of I plus the slope x of I comma yi times h. So this is the Euler's method which we have used to calculate the extrapolating the next solution or next values. However, if you are using the modified Euler's method, that means the Heun's method, what we are going to do is we are going to find out the slope at this point as well as this point. So we are going to find out the slope at this point as well as this point, and then you are going to take the average of these 2 points. I mean the slope point, the slope or average of these two slopes, so that will give you the somewhat accurate solution than the Euler's method. So that is the idea of the Heun's method. So in the Euler's method, we are actually taking we are calculating the slope from this initial point and using the linear interpolation, and we are actually finding out the next step. Okay, so which is this first single step method. However, if we are using the Heun's method, we are actually calculating the same single step method, but we are actually calculating the slope twice at the starting point as well as the ending point, and actually taking the average between these two slopes. That will give you the improved estimation of the improved estimation of the numerical solution. So if you recall the Euler's method, the slope of the beginning of the interval, let us take it as a y I prime, which is equal to the sum of x of I comma y of I, the function of x of y I. This is actually used. It is actually the slope which is actually used to linearly interpolate the solution at y of I plus 1, which is equal to y of I. That is actually we have seen here. That means the f of x of I comma y of I times of that time step. Okay. So this is the Euler's method which we have already seen in the last class. However, the Heun's method, what we are going to do is we are actually using this point, this solution as a predictor solution. That means it actually predicting the next step. That is, this solution is actually using this yi. It actually predicting the y of I plus 1, and this is actually a predictor. It's actually predicting the approximate solution at next time step with the time step of h. So in Heun's method, this is not the final answer. but it is actually the intermediate step, which is actually the predictor step. Okay, so let us take this yi plus 1 as a predictor, so I can take it as a subscript, superscript as 0. So yi plus 1 of 0, which is equal to y of I plus f of xi yi into h is the predictor step, which provides the estimation of the yi of I plus 1 that allows to calculate the estimated slope of the interval. So we can using this predictor step, we can actually find out the slope of y of I plus 1 prime, which is equal to some f of x of I plus 1 comma y of I plus 1 of 0. So using this slope, we can actually find out the another slope, that is called y of I plus 1 prime, which is equal to at this point x of I plus 1 of using this f of y I plus 1 of 0. Therefore, now we have two slopes, y of I prime and y of I plus 1 prime. So what I am going to do is I am going to combine these two slopes, this equation 1 and the slope 1 and slope 2, and I am going to combine these two slopes, and I am going to write the another equation. Let us take y prime of dash, which is equal to yi prime plus yi plus 1 of prime divided by 2. So that is going to be the solution, which is equal to f of x of I comma y of I plus f of x of I plus 1 comma y of I plus 1 of 0 divided by 2. Okay, so this is my slope now. So I have taken the slope of this point and this point, and I am going to take the average of these 2 points, which will give you this expression, and I am going to use the same Euler's method by taking this as a slope, so that I can write that average slope of the Heun using the Euler's method y of I plus 1, which is equal to the previous solution, previous value y of I plus the slope, that means f of xi comma yi plus f of xi plus 1 comma y of I plus 1 of 0 divided by 2 multiplied by the h, time step h, which is exactly the Euler's method, but still instead of taking the single slope, we have actually taken the average of the two slopes and then multiplied by the h. So this is actually the predictor. This is a character equation. So that I can just combine this predictor and character equation. So the predictor is, which is nothing but the y of I plus 1 of 0, which is equal to y of I plus f of xi comma yi of time step h. So this is the predictor part or predictor equation, and so the character equation is y of I plus 1, which is equal to y of I plus f of xi comma yi plus f of xi plus 1 comma y of I plus 1 of 0 divided by 2 times of h. So therefore, you first calculate the predictor. That means you can using this predictor expression, you can predict the this slope, this point, that is the next point, and I am going to calculate the slope at this point. Then I can actually take the average of these two slopes, which will give you the character equation, that means the character solution, which is equal to this expression. You can note here that this y of I plus 1, and we also have another y of I plus 1 of 0. That means in the both left hand side as well as right hand side, you have the expression for the y of I plus 1. It can be applied in an intermediate so that you can actually calculate this character method using the iterative fashion. That is, the old estimate of y of I plus 1 is actually used to predict the new value of yi plus 1, and then again this yi plus 1 is actually taken as the initial value for the next time step, next value, so that you can easily find out the y of I plus 2, which is used to repeatedly provide the improved estimate of the y of I plus 1. So when you are using the predictive character method, you are not expected to get the numerically calculated solution is exactly converging towards the exact solution. However, this method provides the improved estimation of the slope than the Euler's method. Okay. So using this predictor expression as well as character expression, we can try to solve the some of the couple of problems so that you can better understand the how this predictor and character method is used to calculate numerical solution of a given differential equation. So the first example is, so you have to apply the Heun's method to calculate the point y of 0.2 of the following equation dy by dx, differential equation dy by dx is equal to x plus 2y, and the initial conditions given as x is equal to 0, and at the point of x is equal to 0, you have a y value as 0 with the time step of h is equal to 0.1. So the slope of which we have to given is f of x comma y, which is given as x plus 2y, and the initial condition x of 0 is equal to 0 and y of 0 equal to 0 with the time step of h is equal to 0.1. So what we are going to do is we have to find out what is the value at 0.2. So we have to find out what is the value of 0.2, which we are going to calculate using the predictor and character method, the Heun's method. So we can take the value of the x. So we know that this x value is x of I plus 1, which is actually varying with the x of I plus h, and similarly you can use the predictor and then the character. So the predictor equation is actually, we know this, y of I plus 1, which is equal to y of I plus sum of xi comma y of I into h. So this is the predictor equation, and the character equation is y of I plus, this is y of I plus 0, and the y of I plus 1, which is equal to y of I plus the slope of f of xi comma y of I plus f of x of I plus 1 comma y of I plus 1 of 0 divided by 2 multiplied by the time step h. So this is the character method. So we know that the initial values which is given as x is equal to 0, we have the value of x is y equal to 0, y of 0 equal to 0. This is the first value which we already know, that the initial conditions. So using this initial conditions, we are actually estimating the predictor and character method for the h is equal to y of 0.2. So you are going to find out the x of 1, which is equal to x of 0, that is x of 0 is 0 plus x of 1, the h value is 0.1, so that the value of x1 is equal to 0.1. So x2 value is 0.2 plus 2 times of y20 is 0.016, so that I can estimate the solution. The final value is 0.0221. So that is my y2 value at the time step of 0.2. So that my y of 0. At the value of y of 0.2, I got the value as 0.0221. Okay. Now, if you know this exact solution of this equation, then you can just compare this solution at the value of 0.2. Then you can find out this, estimate the error between this value and the approximate numerically calculated value. Then you can find out how this error is actually, what is the error between this exact as well as a numerical solution. Okay, which I will give you as a homework. So we can look into the next problem. So the next problem is, so the given equation is 5x into dy by dx, which is equal to 100 plus 5, with the initial condition of x is equal to 0.5, value of y is equal to 20, So we have to implement the Heun's method to solve the y value at x is equal to 1.5. Okay, so the value given is 0.5, the initial value. So you have to find out the truth, the numerically calculated numerical solution at x is equal to 1.5 with the time step of 0.5. Okay, so every increment of 0.5, you have to calculate the solution at x is equal to 1.5. So the solution will be, so just before going to this equation, I can just rearrange this equation as dy by dx. This is equal to 100 plus y divided by 5x. I can just rearrange this equation, and we know this predictor equation is y of I plus 1 of 0, which is equal to y of I plus f of xi comma yi times of h. Similarly, the corrector equation y of I plus 1, which is equal to y of I plus f of xi comma yi plus f of xi plus 1 comma yi plus 1 of 0 divided by 2 into h. Okay. Now what we are going to do is, we have to given the given value is at xi which is equal to given as 0.5. At this point y of 0 is given as 20. So this is the initial values given, and h is equal to given as 0.5. Okay. So now we are going to calculate the f of x0 comma y0, and this f of x0 is nothing but the f of x0 is 0.5, y0 is 20, and we are going to calculate this value, suppose f of 0.5 comma 20, which is equal to, we already know this slope, right? So 100 plus y divided by 5x, I can just substitute the values of x0, y0 here, so that I can get the value 100 plus y0 divided by 5 times of x0. So the x0 and y0 value is 100 plus 20 divided by x0 is 0.5. So 5 into 0.5, which will give you the value of 48. So my f of x0 comma y0, that is equal to f of 0.5 comma 20, which is equal to 48. Okay. Now I know the slope I have calculated. So using this slope, I can using the predictor formula of y1 of, maybe I can just take it as the first step. I can take it as y1 of 0. This is equal to y0 plus f of x0 comma y0 into h. So I can just substituting this slope in this equation with the initial values. I can find out the y10, which is equal to 20 plus 48 times of 0.5, which will give you the value of 44. So that is my solution calculated using the predictor. That means the exact Euler's equation. So in order to correct this prediction, I can use the first order derivative of the second point, so that I can calculate the slope at the second point f of x1 comma y10. This is equal to f of x1 is given as 1.0 comma the y10, which we have calculated as 444, which is equal to 100 plus with the y1 values we have calculated as 44. That means the y10 is 44 divided by 5 times of x1 value is 1.0, so that I can get the value. Just doing the arithmetic operation, you get 28.8. That is the f of x1 comma y10. Okay, that is my slope. So using these two slopes, I can using the corrector's formula, corrector's equation, I can using the I can calculate the correct estimated value of y1, which is equal to y0 plus again f of x0 comma y0 plus f of x1 comma y10 divided by 2 to h. So I know this y0 value, which is given as initial value 20, plus this value y of x0 we have calculated as 48, plus this value which we have called 28.8 divided by 2 into time step of 0.5. So that the final answer will be 39.2. So that is my y1 value. Therefore, at x1 is equal to 1, the value of y1, which is equal to 39.2. Okay, so using this values, we can predict we can just evaluate the equation, and you can find out the y2 value. That is, you can repeat the same steps again using the values of x1 and y1, so that so f of x1 comma y1, which is equal to f of 1 comma 39.2. Okay, so at this point we have to find out the slope. So f of 1 comma 39.2, which will be equal to 100 plus y1 divided by 5 times of x1. So we know this x1 and y1 value now, so that I can just substitute the values 100 plus 39.2 divided by 5 into 1, which is equal to 27.84. So that is my first slope. Similarly, I can using this, I can just predict the value using the predictor formula y2, which is equal to y2 of 0, which is equal to y1 plus f of x1 comma y1 into h. That is equal to y1 value we have calculated as 39.2 plus this slope again, which we have calculated is 27.84. 27.84 multiplied by the value of 0.5 again, which will give you the value of 53.12. That is my y20. That is the predicted value. So again, you can use this predicted value, and you can and using this value, you can just correct the solution. So for the correct equation, I can again find the slope f of x2 comma y20, which is equal to f of x2 value is 1.5 now. The y20 value is 53.12. So I can just substitute this slopes into the same equation again, 100 plus 53.12 divided by 5 times of 1.5, which is equal to 20.416. So this will be the slope for the corrector method. So that I can, using this, just substituting this values into the corrector formula, so that y2, which is equal to y1 plus f of x1 comma y1 plus f of x2 comma y20 divided by 2 times of h. I know all these values. Again, I can easily substitute the values. Y1 value is 39.2 plus y1 value, which we have calculated at 27.84 plus the slope value, which we have calculated is 20.416 divided by 2 multiplied by the time step 0.5. So the value is 39.2 plus this value is 24.128 multiplied by 0.5. The final answer will be 51.264. So that is my y2 value. So at x is equal to 1.5. So if I make a table column of the calculated values, so I and the xi values and yi value and f of xi comma yi. Similarly, the corrector method, the predictor method, y of I plus 1 of 0 and f of xi plus 1 comma y of I plus 1 of 0. And the final answer of yi plus 1. So the values which we have calculated for I equal to 0, we have the x0, which is equal to 0.5. The value is given, y0 is equal to 20, the initial values. Using these values, we have calculated the f of x0 comma y0, which is equal to 48, which we have calculated. Similarly, the y1 of 0, which we have calculated as 44, and so f of x1 comma y1 of 0, which we have calculated as 28.8. So the final value of y1 is equal to 39.2. Similarly, for the I equal to 1, the next iteration we have calculated the x1 is equal to 1, y1 which is equal to 39.2. So f of x1 comma y1, which is equal to 27.84, which we have calculated. Again, y2 of 0 is equal to 53.12, and the credit for the slope for the character method is f of x2 comma y2 0, which we have calculated value is 20.416, and using this we have calculated the y2 as 51.264. 51.264. So using this, again you can improve the, doing the other iteration at I equal to 2, you can find out the x2 is equal to 2 of at the value of 1.5. You can calculate the yi value and the slope values, which you have to do it as a homework and show me into the next class. Okay, so that's all for now, and we can see how the program, the Fortran program is write and return to implement this predictor and character method and solving this equation, and we can compare this solutions with the Euler's method solution, and then we can discuss the difference between the Euler's as well as the modified Euler's method. Okay, thank you.